Got the recording. Okay. Okay. Hmm. Okay, welcome. We're going to be implementing this using C++, and I'll be using CLion. So let me create the project. So the industrial Internet of Things consists of interconnected devices, machines, and sensors to improve efficiency and productivity by enabling automation. IIoT is an extension on IoT to augment the capabilities of industrial sectors such as energy, manufacturing, transportation, aviation, water management, and smart cities. The theme for the practical assignment this year is analyzing the data collected by IIoT sensors and using it to make meaningful decisions. So we're going to be creating an application that's going to collect data through the use of IIoT sensors, and then we're going to use that data to make meaningful decisions. So let me create the project. So it's an industrial internet of things. So industrial internet of things. So let me create the project. I'm gonna make it an executable and then give it a name. Industrial Internet of Things, and then create. And then there we go. There's our project. And then I'm gonna close that. And then I'm just gonna add the using namespace keyword so that I don't have to write this over and over. I don't want to have to specify which namespace. So I'm just gonna include that line of code that says that whatever I'm using is from the standard namespace. So let's look at the problem. So assume that an IIoT sensor collects the following telemetry data from an industrial plant, create a data structure to represent an IIoT sensor, use an appropriate C++ construct for creating data structures that only have data without functionality. So here the keyword is that without functionalities. So I'm gonna need to look for a data structure that I can apply, that I can apply to this problem to come up with a solution. And that data structure shouldn't have functionality capabilities. So basically, the data structure that I'm going to choose, it should be a data structure that does not work with functions. So it only works with data. And the perfect data structure for that is a record structure. So before we do all of that, I need to create the class, the header files, and all the necessary files required for this application. So I'm going to create this because I'm going to create the header file for this IIoT monitor class and its respective source file because it's the one that manages the IIoT sensor. So I need to create those two files. So I'm going to navigate to file and then new, and then I'm going to start with the header file and then call it IIoT monitor and then click OK. And then there it is. It's been created. And then I do the very same thing. And then I create the source file for the IIoT monitor. And then I'm just gonna remove all of that code there. So let's start with the IIoT sensor. Remember that the IIoT sensor is within it's being used within the IIoT monitor class. So that's why I needed to create the header file and the respective source file for it. So now I need to create the data structure. Here it says create a data structure to represent an IIoT sensor, right? And it says use an appropriate C++ construct. So I need to use a C++ construct that that applies to only data. With the class construct, it applies to data and functionality. So the class is not applicable here. I cannot use the class as the data structure to store this information for the IIoT sensor. So it only makes sense for me to use a record structure, because the record structure, you can only store data. So I'm going to create the record structure right now. So IIoT sensor, and then okay, let me undo, and then struct. Then there's the data structure. So I'm going to make comments here. Say data structure representing my IIoT sensor. So this is the data structure that represents my IIoT sensor. So what do we have for IIoT sensor? We have the sensor ID, which is an integer that is computed or solved by multiplying the row index and the column index. So I'm going to create a data member of the record structure called sensor ID. So let's do that. So it's going to be of what type? Integer. And then it's going to be called, let's call it int sensor ID. So I'm just gonna write a comment here so that I'm gonna remember how it's calculated. So times column index. And then I'm going to have the other information. So the next thing that I'm going to put is the temperature. So which is a double. So it's going to be a double dBl temperature, which ranges between 0 to 50. Basically 0 to 0.0 to 50.0 because it's a double. And then we go to the humidity, which is an integer. So it ranges between 0 and 40. So int humidity, which ranges from 0 to 40. Then we're gonna have the pressure, which is a double. So we're gonna have dBl pressure, which is a double. And then that ranges between 0 and 40. So it ranges between 0.0 and 40.0. Then light intensity. It's a double, which ranges between 0 and 200,000. So double dBl light intensity, which ranges between 0, it's a double, so it's 0.0, and 200,000.0. So there's my data structure. It only accepts data. So I chose the correct data structure, which is a record structure. And this structure represents what? An IIoT sensor. And then this is the data for each IIoT sensor. And then let's go back. So Now I need to create the class to represent an IIoT monitor. So I'm going to copy that and then create the class. So create the class that represents IIoT monitor. So class IIoT monitor. And then now we need to check what should be within the class. So it manages a dynamic two-dimensional array of IIoT sensors. So with 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 the class, right? If you check the syntax of a class and a record structure, if you notice they're identical, they're literally identical. Even ending with the semicolon there, they're identical. So basically a class is a record structure 2.0, something like that. So let's say this would be record structure um, record structure 1.0, something like that. So what a class is, it basically extends the functionality of a record structure. So since a record structure cannot have the capabilities of creating functions. I mean, you can indirectly implement them through function pointers, but it's not literally a function. It's just a pointer to some function. So with the class, it extends the record structure and provides extra functionalities. You can have functions. You can have you can access the you can determine the level of access through access modifiers. So by default with the record structure, right? Everything by default is public, and that's a problem. So for example, let's say I had a record structure for some company, right? So let's say it's a Tesla record structure. Let me not say Tesla. A, a let me use a bank. So let's say it was First National Bank client. So let's say this was a record structure representing the First National Bank client. So it represents each FNB client. So how would it be structured? So you'd have the properties or the information about each client. For example, the PIN. So there would be a PIN, something like this. And then there would be, let's say, string str address would be your name, string name, str name, and then int let's say bank account number, and then int CVC code. So it will have the following information. The problem with this, right, is that if everything is public, this means that anyone and everyone has access to this information. So that means I would literally just go to my browser and then search someone famous. And then let's say, for example, I would say um, Elon Musk's banking details. I would do that, right? And I would get the information because let's say Elon Musk was using First National Bank. So I would be able to retrieve his information because it's been made public by default. And that's a problem with that. There's a problem with that. And since a record structure cannot provide functionality, I mean, you can tweak it, but by default, it's not meant for you. It's not meant to give you back functionality. So you cannot implement functions within the record structure. So now it becomes a problem. So how am I going to denote that specific members of this record structure need to be kept private and some need to be kept public? How do I determine or specify the level of access that each client has? So, for example, the PIN, you'd want it to be private, should be only known by that specific client. And then same here, because all of those details can be used to make transactions. Even the address need to be kept private. The only thing that we can make public here could be your name, but because by default your name is public. And then yeah, so how do we do that with and still be able to do do the things that we still want to do? For example, want to get the PIN from the user, we want to access the PIN, do all of those functionalities. How do we do that after specifying the level of access? So you see, it becomes tedious when you working with the record structure. I mean, you can tweak it, but it's gonna have a lot of work. It's gonna be a lot of work. By default, a record structure's purpose is not meant to have functionalities, level of access, things like that. So what we need to do is we need to create something that that is an upgrade of a record structure. I mean, it's still a beautiful way to create an application to solve. So it's a beautiful approach to solve a problem because you can encapsulate data within some data structure, it, which is a very beautiful approach. So how do we do that without losing the functionalities that it currently has? We use what we call a class. This is a class. It's basically an advanced record structure. It's an extension of a record structure. It's been improved. It's like an improvement or an improved version of a record structure. So you can imagine it's like record structure 2.0. So yeah, so we need to use a class for that, because with the class, I can say which elements should be public, right? Which variables or member, we usually call them member variables or member functions. So which member variables or member functions should be kept private to the user, because some details or some information is meant to be private. Only it's only meant to be known by you, so it should be private. And some information can be public. So there's the beauty in that. I can specify the level of access, and then I can also create methods now. I can say define a void function, a void member function, basically a function that doesn't return anything, and say, for example, set let's say for example deposit, and then it takes in some amount. And obviously it's going to be an unsigned positive value, so unsigned int. So I can define a function in a class. So that's perfect. That's exactly what we want to do. So the class is very important because you still have the same capabilities of the record structure and more. So you can specify the level of access, the function. So you don't have to do the complicated way of working with function pointers, because I mean technically you can't define a function within a record structure. You can't define it here. The structure for defining it, you'd have to make it a function pointer though. So you'd have to say the return type. Let's say it's a void. I'm creating the exact same function here. So it's going to be a void, and then I'm going to put in brackets the name of the function, and I'm going to make it a function pointer. So I'm going to say pointer and then the name of the function. What did we call it? Deposit. So I'm going to call it deposit, and then I'm going to put in another pair of brackets for the parameters. So for the parameters, I need to always start with a pointer to itself, to the current, I would say, I don't want to use instance, but to the current record structure variable, something like that. So I would have to have something like this, self, a pointer pointing to myself. And then after that, then I can now provide the unique information about the parameters that are required in this function pointer, which is that unsigned. And there we go. I was still able to make the function, but notice the difference. This is far more complicated than this. I need to keep track of the pointers. There's a lot of pointers involved. And if I don't dereference and point to the right locations and things like that, it can affect the performance of my application. My program might crash, and I won't even know how to fix it or what's the issue. Most of the time that happens. So with the class is very convenient, it's very simplistic. It's extra functionalities, and we are literally creating the function. We are not taking the long route towards creating a function. So for example, with the record structure, you'd have to create a function pointer. So you have to work with pointers. Here you just make the function. Done. That's it. So now let's let's add the information required in IIoT monitor. So IIoT monitor, remember that it manages a dynamic two-dimensional array. Oh, but I forgot to mention that by default, everything in a class is private. Since this, by default, it was public, and you saw the issue with that. For example, I'm storing each client's banking details or banking information. If I made that public, by default, it becomes a problem, because now I can just, what's stopping you from going to Chrome or Microsoft Edge and typing, asking for any celebrity's banking details, and then going to that bank app and then logging in as if I am that celebrity, and then transferring myself a specific portion of his worth, of his or her worth. And that becomes a problem. So you usually don't want to do that. That's illegal, that's unethical. So in order to avoid that from happening, classes had to be created. They add extra functionalities and things like that. So by default in a class, everything is private. Then you specify what you want to make public. So in order to simplify this, I'm going to have access modifiers put in place to specify what is public, what is private. So that's what I'm going to do. So I'm going to put the private access modifier. And then within anything after this colon on a new line, but there's a tab, there needs to be a space there. Anything that I put from here, it's going to be what? Private. And then anything I put here, it's going to be public. So for the sake of your code looking neat, I'm going to put a tab there. I'm just going to do this, put a tab. And then do that, put a tab. So let's implement it. So it manages a dynamic two-dimensional array of IIoT sensors. So that means I need to add dynamic, and it's dynamic. That means it's going to be dynamically allocated. So it's basically the opposite of a fixed array. So what's the opposite of a fixed array? How do we represent that in C++? We can represent that through pointers. So each pointer points to, basically it represents a dimension. So here I'm supposed to create an array, the dynamic two-dimensional array of IIoT sensors. So what is IIoT sensor? It's this one, this record structure. So I'm going to copy that, the name of the record structure, and then do that, then put a tab. And then remember what he said, each pointer represents it represents one dimension. So if I have one pointer, that means it's a one-dimensional array. It's a dynamically allocated one-dimensional array because I'm going to be allocating it after getting the size elsewhere. The size was lagging, so now we're back. So as I was saying, each pointer represents a dimension. So if I put one pointer there, it's equivalent to me saying it's a one-dimensional array, but it's dynamically allocated. So that means the size is not predetermined. We don't know the size beforehand. I'd have to get the size elsewhere from the user. So if I have one pointer, that's one-dimensional, but what dimension do we want? We want a two-dimensional. So I'm going to put two pointers. So I'm going to put another pointer there. And then I'm going to call it sensors, right? Because it's a two-dimensional array of IoT sensors. With classes, okay, I'm just gonna with classes, there's two ways you can create member variables. You can just name them like this, or you can put a prefix, an underscore prefix, so that this is just to avoid having to use this operator. So most of the time, you might see other people using the underscore to avoid using this operator. Because, for example, let's say I wanted to, okay, we'll get to that part. Let me just leave it as sensors. We'll get to that part. We'll get to that part about this operator. So the IIoT monitor class must contain the following: the number of rows, which is the height, and the number of columns, which is the width of the area covered. So I need to specify that under private because remember that the way a class operates, everything by default is private. So what I'm going to do is that I'm going to make everything that's a member variable private. Then if I want to access something, if I want to access the value of a specific variable, I can create what we call an accessor for it. Or if I want to change or mutate the value, I want to create what is called a mutator. Or yeah, so basically they're usually called getters and setters. A getter being an accessor function, and then a setter being a mutator function. So let's create the rows and the columns, right? So I'm gonna have, okay, okay, let me just create like this, int rows, right? And then I'm gonna have int columns. This to represent the height and the width of the area covered. So the rows represents the height, and then the columns represents the width. So there we go. So let's see, a two-dimensional array. Yeah, we did create that, problem solved. A set of constructors, right? So what is a constructor? So if you go inside your main.cpp, right? The entry point of the program, basically what gets loaded when you click the play button, the run button, or yeah, it looks like a play button, but it's a run button. So the main function is basically the entry point of your program. If in order for you to compile or to run a C++ program, you're gonna need an entry point, what we call a main function. or a main.cpp, and it has a main function. So this is what gets invoked. So anything that you place in here, it's going to be run as C++ code. So I'm going to go inside of my main.cpp and then create remember that a class is the same as a record structure, right? But it's an improved version. So if you remember, if you have a record structure, you can just use the name of the class, the name of the structure, name of the structure, space, followed by the name of the variable. If you want to create the variable of the record structure type, you would have to create it like this, right? So that I can access the data members of the record structure via this variable. So it's the same thing. So the only difference is that it's no longer the name of the structure, it's the name of the class, followed by the name of the variable. So what's the name of our class? It's IIoT monitor. Okay, why isn't it showing me suggestions? It's like it doesn't know about IoT monitor. Well, how is it supposed to know when you haven't told it about IoT monitor? So where is the information stored about IoT monitor? It's stored inside the header file. This is where we've made the class. So I need to include that header file within the main.cpp file. So I'm going to say hash include IIoT monitor like that. And then what happens is that with the hash include command, what happens is that it just does this. It copies everything, and then it comes here, and then it pastes it like this. So that's how it will be able to know about all of these things. So let's try that again. Let's say IIoT. You see, now it's showing me the IIoT monitor and the IIoT sensor. So let me create an IIoT monitor object. Basically, the variable that we create and we use the name of the class as the data type. That variable is no longer called just a normal variable. It's now called an object, because what a class is in any language, what a class is it acts as a template, as a blueprint. So a class is like we're basically saying, okay, here's the plan to build a house. I'm gonna use these tools in order to build the house. And then now inside of my main, that's me building the house. So it becomes an actual object. So I've put the plan into use. I've executed the plan. So it becomes a tangible thing. So it basically any language that uses object-oriented programming approach, it mimics the real world that we live in, that everything is an object. For example, the chair that you're seated on right now is an object. The TV that you watch is an object. The computer that you're streaming on while you're watching this recording is an object. So everything is treated as objects. So it's the same concept. So when I create this variable here, I can, to make things simple for me and to know once I have a lot of code, I'm going to use a prefix called obj, which just stands for object. So obj what monitor, that's what I'm going to call it, and then semicolon. So what a constructor is basically when you create this variable, it's what gets it calls the constructor. So the constructor is the one that's responsible for actually making the object. That's the one responsible for making the object. So when you do this, when you create the object, in essence, what you're doing, you're basically doing this. So let me demonstrate. Then cancel and do this. So let me go to draw.io. So let's see. Then I'm going to save it on my device, create new diagram. editable vector image, then save it on documents. Some template, I'm just gonna save it as some template. So what happens is that when you create this object, basically, when you create this variable called obj monitor, what happens is that it calls the constructor. Then what the constructor does this. It goes here and says, okay, let's build the object. There's the object, it's gonna build it on the heap, what we call a heap. Just imagine the heap is like sort of like a fridge where you put the tools. It's a storage facility where you just store things. So that's how the computer is gonna operate. It operates by using the heap for objects. So I'm gonna use that, and then I'm just gonna shade it blue. And then what happens is that it creates then let me do this, then edit the text. So it's gonna create an IIoT monitor object. It literally creates the object. And in order for us to create any object, the constructor is required. So there we go. I've resized it. Then I'm gonna do this. There we go. So now, since I wrote this one line of code, what it does this. It creates this object in the heap. So after creating the object in the heap, how are we going to reference that object? So we're going to reference it to the obj monitor variable. So then it does this, then it does this, and then there's obj monitor over here, and then there's the object sitting in the heap. And then this object is going to have an address. Just remember what I said, it mimics the real world. So this object is going to have an address. And the address is usually in hexadecimal, I think. I think it's in hexadecimal. So AAC, something like this. And then I'm going to enlarge that. So you can imagine it as this address. And then let me do this. So it has that address. Then I'm gonna use a different shade of color. So it's gonna have, it has that address so that it's able to know where is it located. The computer still it'll be able to keep track of where it's located in the heap memory. So there it is. So what happens is that this object here, this variable I mean, it's going to take the address of the object that the constructor constructed. Basically, what the constructor built. It built this object. So it's going to take an address of where that object is in the heap. And then it does this. It says, okay, I'm going to keep a copy of that. Basically, it stores a reference. An address is referred to as a reference in programming languages. So it stores a reference of where this object is located. So that's why it'll be able to make use of this object and store information and retrieve information because it has this address. It knows where the IIoT monitor object is located. So we have that. Then since now it has that address, it basically means this. Basically means it's pointing to this address. So now it points to that address. So that's what happened in that one line of code. It created this object in the heap, and then it stored the reference to that object inside this variable code that we called obj monitor. So in essence, this is actually a variable that stores a reference. So it's a reference type variable because it's storing a reference, storing an address. So if you don't, if you can create an object without defining your own constructor, right? So if you don't define your own constructor, it invokes the default constructor. So in this one line of code, if you check my class, did I define any constructors? There's no constructor. So it's going to use the default constructor. So it uses the default constructor. And then that's it. That's how you can, and it works the same way. So let's say you wanted to access something inside of the IIoT monitor class. It works the same way as the record structure. You just use the uh, member accessor operator. So you just say dot, there's the information, there's sensors, there's intros, there's in calls, and then you press enter. But the difference between the record structure and the class is that you specified you basically specified you you basically put in place restrictions. There's things that the user shouldn't have access to. And then there's things that the user can have access to. For example, it's showing this squiggly red line here because what? It even gives you the error. Int calls is a private member of IIoT monitor. So it's been declared private. By private, it means that I cannot access it. I don't have any level, I have no level of access to this int calls. So it still works the same way. Use the member access operator, which is that dot, to access the members of the IoT monitor class. So that's that. So let's continue with what we're doing. So now let's define our own constructor. Remember what I said, if you don't define your own constructor, it gives you a default because it's required in order to construct the object. I mean, I know I'm being a bit redundant, but yeah, it's called a constructor for a reason. It's constructing the object in the heap memory. So there we go. So I'm going to need to create a default IoT monitor constructor. So this default IoT monitor constructor, it's basically overriding the default one that C++ gives you. So I'm going to create the default one. How do I define it? It has the same name as the class because I mean, if you think about it, what are you building? You're building an object of this class. So obviously the constructor or the builder itself, we can call it the builder. It's going to have to build this IoT monitor object. So let's do that. So how do you define it? You just put empty brackets like that. So remember a constructor it's automatically invoked when you create an object. When you do this, it calls the constructor. So since I have defined my own default constructor, you can create it like this. You can create it like that. It should run perfectly fine. There we go. You can create it like this because you've defined your own default constructor, right? But remember this default constructor, it does not take in any parameters. You haven't specified the parameters. So it's a default. Basically, it's an we use two terms, default constructor. They're interchangeable terms. Default or no args constructor. So a default or no args constructor is basically a constructor that takes in no arguments. It has no arguments. So what is a constructor? Remember what I said, it's the one that's responsible for constructing the object in the heap. It's required, it's mandatory. If you don't define it, it gives you its own default constructor. So what really is a constructor? It's like a function. A constructor is like a function. It does something. It's a function, but it's basically a function with no return type. You don't even put void. All you just write is the name of the function and the parameters. That's how a constructor is. So that's the default constructor. So when you do this, you're basically saying, I'm going to override whatever is there, whatever the default constructor I've been given by the language, by C++. I'm going to override it and have my own implementation. That's what you're doing in this one line of code. You've created a default construct because it is mandatory for building the object. So, and this one is going to use class constants. So these are just default values. That's all there is to it. And they're constants because it's not going to change. It's just a default. It's something that you're always going to get by default. So obviously it cannot change if it's default. So now we need to create an IoT monitor where the dimensions of the area being monitored and a default value for all sensors are specified. So I need to take in basically all of the things that are in the private section. That's basically what it's saying. I need to take in all of that as input and initialize them. Because remember, at some point, they are private. This information is private. So I need a way to get the values from the user and initialize them without forcing the user to access them because they're inaccessible because they are what? They're private. We've used the private access modifier. So I'm going to create the parameterized one. Parameterized basically means that it has parameters. That's all it means. So what are the parameters? It's an integer and some integer. And the default says the default value for all sensors. So basically it takes in the record structure. I'm going to take in default values. So basically it's the record structure. So I'm going to take in a record structure as my third parameter. So the way you can go about approaching it, you can, if you notice how I've made it, how I've created the IoT monitor here, the constructor, I didn't specify the variables. I didn't name the parameters like this. So I just wrote the function signature because it doesn't really matter at this point. It's just, remember that the class is like a blueprint. It's just a plan. I'm not going to write, and I'm going to use the divide and conquer approach. That's why I have the source file this side and then the header file this side. So the header file is only going to consist of the function signatures. It's unnecessary for me to put variables there. I'm only going to put it in the source file when I write the implementation. So there's the different variant of the constructor. So I can either call this one or call the parameterized one. So if we go back to my main, here I'm using the default one, but I can call the other one and say, let's say I want 10 rows, 12 columns, and then I specify the constructor values, which is the instance ID, the temperature and humidity and all that. But you can also create it like this. You can say IoT sensor, and then you set the default values. Dot in sensor ID, you can just say it's 0, and then sensor dot int humidity is equals to 0. And then once you're done initializing all the variables, you just pass in the sensor with the default values like this. You can do it like that. Or you can just put in curly braces like this and then provide the values in that fashion. It's a shortcut approach. So you can have, say, 20 here. It even tells you what's going on. We are saying dot int sensor ID, you're accessing the sensor ID, and then you're setting it to what? 20. And then I'm going to say 12 here, and then it shows me that you're accessing the dBl temperature and you're setting it to 12.0. So I can use that approach. So as you can see, there's two ways of me creating the object. There's two types of builders. There's one whereby you're just using defaults. So you can imagine you can imagine the parameters of a constructor as like the defaults that you want. For example, you're part of the production of or part of the construction of the house. And then you say, okay, I want the house to be painted blue outside with the dark gray interior, fitted in wardrobes and things like that. That's all of that you're specifying via parameters. So you can imagine this default house is like, okay, You talk to the builders and you're like, okay, just give me a house. I don't care about the specifics. With this type of a constructor, it cares about the specifics. How big the house is, does it have air conditioning, all of those properties. You pass them via the constructor as parameters so that it constructs the object the way with the defaults that you want. So let's see, we are done with that. So let's create a copy constructor. So a copy constructor, it's in the name itself. It's meant for copying. So you copy one object and one object into another. So yeah, it's just meant for copying. That's more there is to it. There's nothing fancy about it. It's just meant for copying. It just copies whatever the contents of that object and then has its own version of that. It has a copy of that. And then it changes whatever way it wants to change it. So this could be useful. For example, you want to make changes, but you don't want them to be permanent. You want to see the results first before changing them, changing the object states, the state of the object permanently. So how do we do that? How do I define a copy constructor? So it takes in an IoT object. And then, yeah, it just takes in an IoT object like that because I'm going to use, it takes in an IoT object like this. But the problem with this approach is that we need to, it's going to make your program slow because we're copying the object itself. The quickest way to copy the object is to copy it by reference. So I'm going to actually pass the reference itself. That's going to be way quicker. The reference is basically an address. So I use the address of operator there. That means I'm going to take in an address, which makes the application way faster. And then since it's not meant to change the underlying data, it's just meant to copy. I'm going to put a prefix called const, which means that it's going to be constant. I'm not going to make any changes. I'm just going to copy or access, only just meant for accessing. I will access and then take those values that I've accessed and store it and make my own copy. That's all there is to it. So I'm going to leave it like that. And then I need to create a destructor. So remember what he talked about. An IoT monitor is meant for constructing, right? So after constructing, we don't want to leave the objects dangling in memory. We want to get rid of them, right? So that's where the destructor comes in place. The destructor is basically, okay, after you're done allocating, whether you use the default or parameterized constructor, when the object is no longer in use, it deallocates that object's memory so that there's no memory leakage. So that destructor is going to mean, you can imagine as like your constructor, it's like, okay, the constructor allocating memory, right? So that means, for example, you can say the constructor is like, for example, you're eating, right? You're eating, you're enjoying a nice meal. And then when you get to the destructor, it checks whether you are done eating. Is the plate empty? Or the plate is empty. Then what should happen? Clean the plate. So after the plate is no longer in use, it has to wash it. It has to clean it. That's basically the destructor. After you've created the object. So basically when you create the object via the constructor that constructs the object, you're basically allocating memory for it. So after it's no longer in use, you need to delete the memory allocated previously because I mean, it's no longer being used now. There's no need for us to have the memory allocated. And then we're going to have set sense data function. So this function generates a random sensor for each of the IoT sensor using the range of valid values. This function must be called in the constructor that does the initialization. So basically, when they say this needs to be called within something, that means it's meant to be a utility method. What is a utility method? It's basically a method that helps with whatever you're doing as a programmer. It's not meant for the user. It's just meant for you to divide your code into chunks. And that leads to easier code maintainers. So that's very important. So let's create the function. You create it the same way you'd create it. So this function generates random what? It just generates it. There's no, we're not getting back anything. So it's going to be of type void. So since it's not meant to be known to the user, that means I won't put it under the public section. I'm going to put it under the private section. So I'll go under the private section and then I'll say void because it's not meant to return anything. And then I paste that name of the function and then semicolon. It's that straightforward. Then now I'm going to check what it's supposed to do. It generates random sense data for each of the IoT sensor using a range of valid values. So since I'm within the class, I'm basically what it's telling me, it's like, remember, this is a two-dimensional array. So it basically it's telling me that for each sensor that I have here, I need to randomize the values through set sensor data. So since sensor data, it's within this class, so it has access to this. They're all part of the same family. They're all private, right? So I don't have to say take in an IoT sensor in there. I don't have to do that. I'm within the same class. So I'm just going to leave it parameterless like that. And it's private because there's no information that says it needs to be otherwise. It needs to be public. We don't have that information. So I'm going to use, they say you must use a must create a toString function that returns. You see, now we're starting to see the keyword return. We're getting back something. So it returns a what? A string. Okay, let me use a different color. So it returns a string using the string. So I need to include that library so that it knows what a string is. So I need to say hash include the string library, and then I'm going to say hash include the string stream because we're going to need to use that. Oh, it's okay. It's not called string stream. It's SS stream like this in shortcut. In short, so I need to also include IO stream because I'm going to need to make use of the standard namespace because the string is within the standard namespace. So I'm going to scroll down here and okay, wait, what are we supposed to do? The toString. So the toString, should return what? Okay, so the toString, it's going to be a function that gives a string representation of something to the user. So you see, it's going to be public. So it's going to be public. So we're going to go under the public section, things that should be public. And then I'm going to say toString function. Then I'm going to say string, right? And then to string, then semicolon. So now it's complaining about string. It's complaining because I didn't specify where is string coming from. Remember, string is inside the standard namespace. So I need to specify that it's from the standard namespace. It's from that storage facility code standard. So go inside that storage facility, and I promise you're going to find the string. And then it actually did manage to go there, and then it found the string. Now it stops complaining. So the key part about classes, right? Whenever you have a function that's only supposed to return something, right? It's only supposed to access information or values. It's supposed to access the values, right? And there's nowhere where it states that you need to change the information. So since it's not changing anything, I put a suffix const at the end to say that this function is not gonna change anything. It's only gonna access and return some output. So it won't change the underlying data that I'm working with. It will just make use of that data and give a reasonable string representation of the data. So we have that. So that's it. We are done designing the class, but there's extra things that we need to create. So remember that we have the default constructor. So it's gonna need defaults. So, and these defaults are what I like this one, are basically anything that's under the private section that we haven't initialized, that we will need to initialize, which is the member variables, right? The rows, the columns, and the sensors. Those are the three things that we need to initialize. So I need to create class constants for that. These are called class constants. So you still use the keyword const, but you're gonna introduce a new keyword. So I'm gonna use const, right? The way we normally create constants. So a const int what, and then it's in all caps. So I'm gonna say default rows, and then I say how many rows. Let's say by default you're gonna see a 15 by 15 output, and then I say const int default underscore calls 15, right? So these are my constant, and then I need to create the default values for the IoT sensor, a constant for the IoT sensor. So I'm gonna say const, I can't say int anymore. Remember that the constant that I'm making, it needs to be a replica of this, the member variable. This one, I used int because it's int rows. It's of type int. And then this one is int calls because it's of type int. So I use int. So that's why it's like that. But this one is of what type? It's of a record structure type. So I need to put that there. And then it's going to complain, but we'll get to that. So I'm gonna say default underscore sensor. And then I'm gonna say is equals to what now? That's the question. I can't just say it's equals to like 10. I can't do that because this is a record structure. So with things that involve expressions and, like for example, a record structure, I need to use what I call a const expression. And then this const expression, okay, what's it saying? Const no valuable conversion from into, okay, it's complaining about this integer here because it's expecting a IIoT sensor, something of IIoT sensor type. So how do I initialize this? You can initialize it like this. You can put the brackets like that and then initialize it. I don't know why this is still complaining. Oh, okay, we'll get to that. It's forcing me to install something that I haven't gotten to yet. So let's go up. So I need to start with the ID. So what is the ID? You're just gonna say it's 0, and then you're just gonna use default values. So this one it should be 0. It makes sense to be 0 because there's no -1 row or row -2. It doesn't work like that. It's only starting from 0 and upward. So I'm gonna use 0 as a default, and then this one is a double, so I'm gonna use 0.0. 0.0 like that, and then 0. The next one is an integer, and then I'm gonna use, what's the next one? It's a double, 0, and then another double, so 0. So I'm gonna put two doubles. Okay, now it's my code is becoming very long. So it's two double 0.0 and then 0.0 like that. So there it is in full. We've initialized everything using what we call a constant expression because this is more of an expression than just a single value or a single constant. So yeah, it was complaining about something. We're gonna fix that now. So there's this keyword that's very important when it comes to classes. So if you look at these constants, they're never going to change. They're constants after all. So there's this keyword that is very useful in terms like this. So basically, if I declare it like this, every instance of this class, this this is called an object or an instance of the class. By instance, we're just saying it's a manifestation of the class. Basically, it's a manifestation of the blueprint. It's a manifestation of the plan. So that's another term for it. So every time I create an object, what happens is that the object gets its own copy. So let's say I call this one obj monitor 2. So what happens is that it does this. It just replicates this, the same formula that it used here when it was creating this. Okay, I need to select everything. So I'm gonna select from there and then copy, paste. So what happens is that it just does this. Now you have a separate object and then it's gonna be called obj monitor 2, right? So it's no longer called that, it's now obj monitor 2. And then I'm gonna zoom in so that the text is visible like that. And then I'm just gonna add some color to it. Let's add this color. So there it is. And then I need to do this. Yeah. So that's what happens. It just makes another object and then makes it point to this reference. So it takes the reference and stores it inside this variable. So now this variable becomes a reference type because it's storing a reference to something. In this case, it's storing a reference to IoT monitor object. So what happens is that when you have these constants, right? This is what happens behind the scenes. It creates these constants, right? So you're gonna have default underscore rows. Okay, let me do this. These are the constants because remember each object is what it has. The class, that's what it has. So the object, remember, it's a manifestation of the plan. So it's the plan turning into something solid, into something concrete, something tangible. So whatever we had in our class is going to be what will be stored in the object. So we're going to have default underscore calls there. And then we're going to have default underscore sensor. So it does the same thing for the other object that you had above. It also has default rows and then default columns. Okay, let me put this back. And then default sensor. So you see, they're exactly the same and they have the same values. So now you can see the problem that arises with this. We are storing the exact same value and each object is getting its own copy. That becomes a problem. Now we're wasting memory, wasting space. Each object gets its own copy of the exact same thing. So this is where the keyword static comes in place. It comes to save us. It comes in as like Superman or Batman to save the day from this horror. So it's every time you create an object, it creates its own copy. So each object has its own copy of the three values, of the three constants. I mean, after all, they're constants, right? They're not changing. So what approach can I use in such a way that this doesn't happen? You don't get the exact same copy of the very same thing. So we can use the keyword static. The keyword static, it means that every instance that I use here is going to share. It's going to share these values. I mean, after all, they're not going to change. So it's going to share. So instead of the values being like this, being stored, created in each object, it's going to just say, for example, it stores it somewhere. It's independent from the object. It exists independent from the object. So it's going to be like this, right? And then, okay, let me do this. And I'm going to have default. Okay, let me do this. Let me add color. Okay, it doesn't want me to do so. So let me just do this. Change the colors. Make them all green. So now what it does when you use keyword static, it's like it's always there for every single class, every single object that you're going to create. It's no longer, each class, each object is no longer getting its own copy. They are sharing. So you see it becomes empty like that, and then they share these three constants that are here. So that's what static does. You don't have to waste and keep duplicating and each object having its own copy of the exact same thing. So it avoids that by creating it separately so that in such a way that it's shared. So you can imagine that it's like a piggy bank. So it's like a piggy bank. So imagine this piggy bank that you have. It's imagine that we all had the same piggy bank. Let's say it was the same pig. We all had the same pink piggy bank like this, and let's say it's like 16,000 of us. Why would he buy the exact same piggy bank, whereas we can just use one and share it? If I want to store some money in there, I can just borrow it, and then I store some money, and then I use the money. And then if someone else wants to use the very same thing, they borrow that same piggy bank, and then they use it and store money and then do whatever with the money. So that's, in essence, that's what's happening with the static keyword. You're sharing one thing among plenty of people because you've seen that, wait, we're using the exact same thing. Why not we become smart and share instead of wasting money buying the exact same thing? So it's like, for example, you have, let's say your friends like the jacket that you're wearing, and your friend was like, okay, I'm gonna go and buy this exact same jacket. And then you decide to be like, okay, no, don't do that. Now that's static. That's what static is saying. It's saying, no, don't do that. Don't go buy your own version or your own copy of the very exact same thing that I have. Assuming that as in that friend group, we all can fit the same in the same jacket. So that's the static is like, okay, instead of us instead of us buying different types of the different jackets of and the exact same jackets and the exact same size, there's no need for us to do that. Let's buy one jacket and then share it. Whoever wants it to wear it that day, they can wear it. If I want it tomorrow, I'll come and borrow it and then I'll wear it. We'll share one thing. So that's what happens. It gets reserved separately. And then each object that gets created, it shares, just takes that and then uses it. Instead of it being stored, instead of it getting its own copy, it's gonna waste memory. So we have our constants And we have our methods. I think we are good to go. Yeah, we are good to go. We have everything that we need. Yeah, we have everything that we need. The toString function. Yeah. So let's go to, but let me do a part 2 where we start implementing and writing the code. Okay, I can just combine it. Okay, it's fine. Let me just combine it. Let me continue. So the header file, remember the header file, that's where we create the class, right? The blueprint and everything. I mean, technically you can combine it and put it into one thing. For example, after the semicolon, you just put in curly braces like that, and then you start implementing the function. You can do that, but we're using the divide and conquer approach. So I'm going to create a header file that contains the class, and the class is going to contain signatures, function signatures, and things like that. And then the CPP file is going to be the one that implements those functions. So basically the header file is like, I'm making a promise. I'm like, okay, this is my design. This is my template. These are the tools that I'm going to require. I'm going to require class constants as one of my tools to create the IO monitor, IIO monitor, IIoT monitor. I'm going to need the copy constructor, a parameterized constructor, a default constructor. I want to need all of those details. But I promise, I'm making a promise that I'm going to use these tools. These are the tools that I require. All you need to know for now is that I'm going to require these tools. I'm not going to use them yet to make the IoT monitor, but I'm going to require these tools. That's what's happening in the header file. You're making a promise. So it's like, for example, your friend promised to buy you shoes and things like that. That's the header file. That your friend making the promise that, okay, I'm going to buy you shoes. That's the promise. That's the header file. It's making the promise. And then in the source file, it's your friend actually fulfilling the promise by buying you shoes. That's what the source file is all about. So we're going to do that now. So let's do that. So this is how you implement it. So what I'm going to do is I'm going to copy everything in the class, and then I remove all the unnecessary things and only use the functions. I'm gonna remove all of this. Yeah, the functions are fine. I'm gonna remove all of this, the class constants. Then I'm gonna remove that public access modifier there at the top. Okay, so there's that. Then now, what I need to do before I implement everything, right? Before I fulfill the promise, I need to a hash include so that it knows what IIoT monitor is. So I need to say hash include the IIoT monitor header file. And then since I'm going to be using, okay, I'll only be using a string stream. Okay, I'll be using a string stream and I'll be writing a lot of code in here. So what I'm going to do, I'm going to say using namespace standard, because this is the implementation file. It's going to have a lot of code. Here, there was no need because here it was just a blueprint or just a plan. I was just making a promise that I'm going to, for example, buy my friend the shoes. And then in the source file, that's me fulfilling the promise. That's where the implementation comes. So it's a divide and conquer approach. So let's do that. So in order for you to implement the methods or the properties of the class, what you need to do is you need to remove the semicolon and replace it with square bracket, with the curly braces. I mean, each semicolon at the end, you put curly braces. And then do that. Curly braces, you put them there, done. And then now you need to specify where this is coming from. So because this is a class, it also acts like a namespace. It acts like a storage facility. So you need to specify where it is coming from. Just like with the standard namespace, when you said standard and then you say string, you see it's showing there because it belongs to the standard namespace, to that storage facility. So it's the same thing here. I need to specify that it's coming from a storage facility or a class named IoT monitor, like this, and then the error disappears. And then I do that for every other function and constructor. I implement it there. And then remember now the string is the one that belongs to the standard names, the string. What belongs to this class? It's the name of the function. Const doesn't belong to us. It came pre-installed with C++. This is what belongs to the class. So I need to put it as a prefix there to state that this toString function is coming from this storage facility or this class, just like we did with standard namespace. And then done. And then we go down, there's the destructor. You just put it in the front there because it acts like the function name, like the name of a function. And then now we have void set data. I need to prefix the function name. Done. Void is not part of the IoT. I didn't define something called void. It just came pre-installed. And as you can see, it's highlighted. So it wouldn't make any sense for me to do this. You can't do this. Because what you're saying you've created void. You've defined something called void in your class, a method called void. It's either a method or a destructor or a constructor. That's what you're saying, but there isn't such. It's already pre-installed with C++. So it doesn't belong to you. It belongs to the standard namespace, the IO stream, all of those. That's where it belongs to. So now let's implement the constructors. So now I'm gonna need a way to reference the parameters, right? So I don't use them. I don't create it as a function signature anymore. I'm going to find a way. I'm gonna create a variable there because I need a way to reference those parameters. So it takes an int calls and int rows and that, and then I'm gonna say IoT sensor. And then I'm gonna have here obj monitor. There we go. Yeah, that's pretty much it. And then now let's write the implementation. So I'm getting this information from the user. So what I'm going to do is I'm going to initialize. Remember this information. I need it so that I can initialize the variables inside of my class. So let's do that. So I'm going to say int rows, the one inside of my class, is equals to this int rows, is equals to int rows. But now the problem is that now the int rows look the same. How will it distinguish between which one is which? Because as you can see, now it's complaining, it's making an error saying the value is never used. So it's like, okay, it's confused, like which one is which. Because if you check in my class, I named it the exact same way. Int calls and int rows. That's exactly how I've named it. So in order to distinguish between which one is which, you can use this operator. The this operator, it means that it stores the pointer to the current instance. So it's like, for example, obj monitor, point, something like that, like this. It's exactly like this. It stores the current instance. So it's, for example, I've created a variable called obj monitor. How does it know that I'm currently referencing obj monitor. So for example, when I say obj monitor dot toString, how does it know that, okay, call the toString for obj monitor? It keeps track of that by a means of this operator. So it means this current instance or this current object, which is basically a pointer object because it works with pointers. So we can use that so that it knows, okay, I'm referring to this current instance's rows. There we go. And you see, it even highlighted it in a different way. It's now telling me in which storage facilities it belongs to. It belongs to the IIoT monitor class. As you can see, it belongs to that class. Now it knows where it's coming from. That's why in some examples, they just avoid this approach and just say, let's say, for example, we've made the columns underscore calls. We named it something different. Underscore calls. So that means I can just say this underscore calls is equals to int calls. And it will highlight accordingly. You see, it's highlighted the same way as this one to show that it belongs to the class, belongs to IIoT monitor class. But I'm just, for the sake of getting familiar with this operator, you guys are gonna have to use this approach. I'm just gonna use this approach that it becomes second nature, that you know that there's something called this operator. So we have that IoT sensor. Now we need to set the IIoT sensor. So this is gonna be set for every single IIoT, every single at every single index, right? Because there's more than one. It's a two-dimensional array of IoT sensors. So it's going to be initialized for every single sensor, those default values. So now I'm going to say, now I'm going to allocate memory for the two-dimensional array. Remember, it's dynamic. I have the size now, as you can see, there it is, the height and the width, the rows and the columns. So now I need to allocate memory. So I'm going to say sensors. How do I allocate? I say new int. No, new the type. What is the type? The type is of type IIoT sensor. So new IIoT sensor. Remember, it's a pointer point. So remember what he said. Every single pointer, it acts as a dimension. So I'm gonna remove the outermost pointer and allocate that for that dimension. Now I need to specify the size of that dimension by taking in the number of rows like this. Or you can start with the columns. It's up to you, but you just need to be consistent with the way that you're approaching the problem. So that's how you allocate memory for it. You replace it with square brackets, and then you provide the size inside of the square brackets. In this case, we're getting the size from the user. Okay, I'm just gonna do this. Let me see something. Yeah, I'm just gonna use the rows inside of this class because I feel like when I just use int rows, it's gonna get confused which one is which. So I'm gonna do that there. Then int r, and then I'm gonna go through each row because the two-dimensional array, the way it works, right, is that for example, for each index, we have an array of something. So it basically, a two-dimensional array is like this. So for example, if at each index, you have another collection. So let's say I have a vertical collection like this, and a vertical array like that. So in order for me to mimic something, to make it two-dimensional array, at every single index, I need to have another array. So it's going to have another array here. So for example, that array it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, like this. And then I do the same thing. Remember, it's at every single index, like this. As you can see, now it's a two-dimensional array. It mimics a matrix. So we're gonna use that approach. So that's why I need doing a for loop to go through every single row and then allocating it to the same number of columns. So row is less than this and rows, and then r plus plus. And then I'm going to say sensors. Remember that it's for every single row. So I need to index now. Remember, I have allocated for my dimension. So the way it works, the outermost pointer that you've allocated, it's like the first dimension, right? So that's that's where the first square brackets are gonna go. So the first dimension I allocated it to rows. That's why I'm allocating to every single row. And then I'm going to pass in the variable that stores the current index. Because remember, I'm starting from this index and stopping at the index before this one, before this value, the actual number of rows. So I'm gonna use R there. And then I'm going to say is equals to new. Okay, IIoT sensor again. Remember, it was this pointer. So after you've allocated the pointer, it's no longer there. You don't have to put it anymore. So now I'm left with only this pointer, the innermost pointer, or the innermost dimension, because each pointer represents a dimension. So I'm going to replace that pointer with what? Square brackets. And then I'm going to specify the size of the of that dimension. And then now at every single, remember that at every when it's like this, when it's a two-dimensional pointer of IoT sensors, right? It means that at every single index. So if I start at 0, that means at every single index, you have a what? An IoT sensor at every single index. Not necessarily index, at every single coordinate. So at every single row and column. Because if it's two-dimensional, it works in terms of coordinates. X, Y coordinates, in this case, R in column, R and C, row and column. So I'm going to iterate through all of the columns now because we do have the columns dimension allocated, which is the one that comes after the first one. So it's going to be from 0, column C is less than this, and calls like that, C++. And then, oh, okay, I forgot to put the dash there. And then I'm going to say sensors at a specific row and column. You see, there's the XY pair coordinates, sort of like coordinate system. So this is equivalent to me saying just X and Y. It's equivalent to doing that. So at that specific coordinate, what do I want it to set to this default that I'm getting from the user? So I'm gonna do that and say sensor is equals to sensor. That's the default that I'm getting from the user. And then there you go, no errors or nothing, because it's a two-dimensional pointer of IoT sensor. And at every single index, I'm setting it to an IoT sensor, because at every single coordinate, it is an IoT sensor. By coordinate, it means that the row and the column. So it's like this. Now I have the column 0, 1, 2, 3, 4, 5, something like this, right? So you can imagine at every single coordinate. So at row 0, column 0, there's column 0, I have an IoT sensor. And then in the next column, I have another IoT sensor. In the next column, but it's still in the same row, I have another IoT sensor. Then the same applies. So as you can see, which is fine, that means at every single coordinate I have an IoT sensor, just an IoT sensor. When I say IoT sensor like this, it basically means this. Okay, it basically means like I'm just saying this. That's basically what it means at every single index. That's basically what I'm saying. So at index 0, you have IoT sensor like this. And then index 1 is the same thing. It's like this. At every single coordinate, no, I shouldn't just say index. So yeah, just keep that in mind. So that's why this is allowed. So now let's implement the default constructor. So with the default constructor, we're basically doing this very same thing, this. So I'm going to show you what we're going to do the very same thing, this. But remember that we're not getting any of these values from the user. I'm making use of default values. So that means I'm going to use my class constants. So I'm going to use default rows here, and then default calls there. Wherever I have this line of code, I'm going to use default. Okay, that's fine. And then I need to change this to default sensor like this. So as you can see, it's exactly the same code. It's exactly the same code. The only difference is that with the default constructor, it's working with defaults, basically class constants. So how do I avoid this thing of copying and pasting? So I use what we call constructor chaining. So I chain the implementation for this class to another class. So I just copy whatever another class is implemented. And that is possible between constructors. So I'm just gonna do this and then say IIoT monitor like that. And then what this means is like, okay, chain this implementation or this constructor's implementation to this constructor's implementation. So it's constructor chaining. I'm chaining my implementation as the constructor to a different constructor's implementation. And then remember, this one takes in parameters like this, right? So I need to provide the parameters. So I pass in the defaults. It's default rows first because I take in the rows first, int rows first, and then comma, followed by the columns. I'm using default columns because remember, it's a default constructor. So it only works with defaults that I have defined as reasonable defaults. So there it is. So when you do it like this, when you do constructor chaining, you are doing this exact same thing here, but it's gonna copy it behind the scenes. So I'm just gonna cut it like this. So when you write this, when you chain this, you are basically saying copy and paste this code here. Where you see this in rows, replace it with default rows. Where you see the second parameter, which is int calls, replace it with default columns. And then where you see sensor, we've used it here, replace that with default sensor. So basically, it just copies and pastes this, but with those changes. You see, there's default sensor, default rows, default columns. So I'm still doing the same thing, but I won't write the code. I'll just do constructor chaining. It'll chain its implementation and just copy this. That's all it will do. And then change whatever values that this one is passing and use defaults and use these defaults. Okay, so now let's implement the copy constructor. So the copy constructor, right? It's basically us copying the state of an object from one object to another. I copied that object into my own. So it's basically what I was doing and what I was demonstrating here. So whatever current values this object has, I'm just going to, okay, let me not use that one. So whatever this object's values are, whatever it currently has, the values, the rows, the what, the toString, everything. Copy that and make my own copy. And then it's going to work with that copy. This one is still existing, the one that we've copied from. We just made a copy of it. It's basically me saying copy paste. So it's like I'm using a printer. So this copy constructor behaves the same way a printer does. So you're printing information. So let's do that. How do we do that? So remember that this is a two-dimensional dynamic array of sensors class. So we're managing a two-dimensional array. So I just need to copy what's in the two-dimensional array. That's how I make the copy. So I do this, and you can also, what is this? You can also chain it if you want to have defaults. You can chain it, the object to give it defaults. Remember, it's still a constructor, but it's a copy constructor, this one. So use the same approach, say IoT monitor. You chain it to the, basically when you chain to the one that is the most parameters, which is always going to be this one with 3. And then you use this. Remember, this is the variable that I use. This is the variable that I use to access. So I'm going to say obj what int rows like this, and then comma obj int calls, and then obj, and then you're gonna have default, yeah, whatever. But I guess no, I guess we can do it like this. Let's use the defaults. Let's use that default, the defaults that we've defined, because there's no way you'd want to define defaults for something that you're just making a copy of. So we won't ever get that from the user. I'm just gonna use the defaults that I've previously defined. So I've changed it to that constructor. So I'm gonna allocate memory and do everything for the array. I'm basically gonna do this, but then use defaults. So now I know that my array is ready. It has memory. I've allocated for it. It has default values. So now let me just copy. And this is important because I need to allocate memory like I did here. It's very important for me to chain that. So now what I need to do is copy the array from this current object to this object. So how do I do that? I say for int r is equals to 0, r is less than int rows slash rows plus plus, and then wait. No, I cannot use defaults. Remember that if I use default rows and columns, it's not going to be of the same size. So, you know, I need to use that approach that I was using. If I want it to be of the same size, I'll just access the ones that are inside of my class, because those are the ones that this object it has the size of. So int calls, and then okay, the sensor can just be default. That doesn't really matter. Yeah, the only important thing is the dimension, the height and the width. That's very important. So, and then now I'm gonna do this and say int r is equal to 0, c is less than, int calls, and then c plus plus, and then now we need to copyright. So I'm going to say the value of the sensor should be copied to this object that the value of this object that I'm passing. So I'm going to say is equals to this object that I'm passing, dot its sensor values. So it's just going to copy the sensor values of the object that I'm passing into the current object, the current instance, which is exactly what we wanted to achieve. Let me see if I cannot add, okay. Yeah, I can add documentation. I can say this is the object we want to copy from. That's obj monitor. That's the object we want to copy from. So I'm copying from this object. What am I copying? It's the contents of its array or the values of its array. Because this is a class that's managing a two-dimensional array. So everything is in the two-dimensional array. So now let's deallocate. Remember we have rows and columns, right? So the way you deallocate, it's basically the opposite of the way you allocated. So you start by the outermost. So which is the columns. So that means I need to go through every single row and column. No, every single row, I mean, and delete the columns dimension or the columns dimension. So delete the columns dimension at every single row, at every single row index. And then once I'm done, I'm going to say delete the sensors, the dimension for each row, the whole row dimension. And now I'm done. Now I need to make sure that it's not pointing to anything. So I say now pointer. So point to now. Basically it points to now. And then I'm done deallocating. And then with the string, we're gonna get to that. We need to work on generating random values. So it's, wait, should it be random values or what? Yeah, we need to implement the set sensor data. The set sensor data function is a function that generates random sense data for each IoT within that range. So I need to create a generate random function. So this generate random function, interesting. So these values that I have are all at different types, right? They're all in, okay, it's fine, it's fine. I'm just gonna make the random function return an integer. And then where I have doubles, I'm gonna cast it to a double. So this generate random function is gonna return an integer, and I'm gonna call it generate random. And then it's gonna take in a lower range, and then int an upper range. Then copy. And then I'm just gonna implement it. Okay, right here. Remember the thing that belongs to the class is the name of the function. So I need to put it in front of the function name. Int is not something that belongs to my class. I didn't invent that. That came from C++. I didn't invent that. So I can't put this I can't put this line of code that specifies which storage facility this thing is stored in front of the int type, because int is not part of my class. Like, it's not something that I defined. It's neither a member variable nor a function, nor a constructor, nor a destructor. It's none of the above. So I don't have it. I need to put it in front of the function name. That's what I came up with. So how do you find the random value? So I'm gonna need the ctime library, and CSTD. So I'm going to include C time library. And what else am I going to need? And then before I do this, I need to seed the random number generator using the srand function, then call the time function and then pass a null pointer so that it generates unique random values. So that it generates unique random values. So there's my IIoT monitor. It includes the C time. So I think that should be fine. That should be the only thing that we need now. So basically the way we generate a random value, right? Just recapping. You check the range that you're the lower and the upper bound, right? That's why I'm taking them in as my inputs to this function, as my parameters. So I'm gonna have a starting point, let's say 0 to, okay, let me use a number other than 0, 3 to 8. How many numbers are those? We can check by counting, right? So I started 3. 3, 4, 5, 6, 7, 8. So this is going to be 6 numbers. So the formula for finding exactly how many, to find the range and generate a value within that range, the formula is simple. You subtract the upper bound, you subtract the lower bound from the upper bound. So upper bound minus lower bound, you get an answer. But that answer is always going to be short by 1. So you need to add 1. So let's test it out. So if I say 8 minus 5 minus 3, I mean, is equals to 5. But how many values do we actually have? It's 6. So that means I need to add a 1 and get the actual number of the actual range. I'll say the actual number of elements that I need to generate. Elements that I can generate, which is basically the range. That's the range. It's gonna be 6 values, right? I'm gonna have to generate 6 values. So the 6 values that I'm going to generate, right? I need to specify, I can also specify where it's starting from. How, let's see that now. So how do I generate a random value? I say return, I make the function return, and then I call the rand function that randomizes, just returns a random value. It returns a random value, but it's not within the right range that we want. So that's why I need to add extra arithmetic to it. So I'm going to say use the modulus operator divided by the range, right? How do you find the range? Let's calculate the range. Okay, let me just write it here. Remember what we said, the range is the int upper minus int lower, right? And then I add 1 to it so that it gives me the actual range, the actual number of elements. And then now I need to specify where it should start from. How do I do that? After finding the remainder, after seeding, after no, not seeding, after finding the remainder from this random function, I need to add the int lower. So when I add int lower, what it does is like, okay, let's basically hear what you're doing when you say modulus, the range. Modulus int upper minus int lower plus 1. What you're saying is that generate 6 numbers. That's what you're saying. But then when you add int lower, now what you're saying is that start from 3. So if I start from 3 and I'm generating 6 numbers, where am I going to stop from? So let's see. 3, 4, 5, 6, 7, 8. How many values am I generating? 6. So it still makes, I'm still within the bounds, the range. And then starting from 3, there it is. So we've achieved the randomizing function, the randomization of values. So this is the function that's going to randomize values. So now we need to, okay, let me just add documentation for this. This is the lower bound of our range, upper bound of our range, and then return a random integer between int lower and int upper. So that's what this function does. So now let's set the random data, right? So I need to randomize each value. So the way I do that is and this is for each, remember that there's more than one sensor. It's a two-dimensional array of sensors. So at each coordinate, I have an individual sensor. So this means I need to look through every single sensor. So I need to say int r, then r is less than int rows, and then r plus plus, and then I'm going to say for int c is equals to 0, and then c is less than int calls c plus plus. And then now let's randomize, right? So we need to randomize the values. So what I'm going to do is I'm going to randomize the values, right? So I'm going to say sensors at that specific coordinate, RC coordinate, dot, now I access the sensor ID. How do we calculate the sensor ID? If you check, it's the row index times the column index. So what I'm going to do is I'm going to need this over here. I'm going to need this so that I can see the ranges and stuff. So I'm going to put it there at the top like that. And then it's the row index times the column index. What is the row index? What value stores the current row? It's R. So that's the row index. Times what value stores the current column? It's the C variable, which is C. Done. We've set the sensor ID. And then I'm going to say sensors RC dot dBl temperature is equals to a random value between this range. So, and it's a double, right? So I need to cast it to a double. And then I'm going to call the generate random function to generate a random value between 0 and 50. Done. We've generated, and then I'm going to generate for the other values. So dot int humidity. This is an integer, so I don't have to worry about casting. So between 0 and 40. And then sensors are C dot dBl pressure is equals to, okay, this is dBl pressure. So I'm going to say cast it to a double because it is expecting a double. So I'm going to have from 0 to 40 again. So 0 to 40. And then sensors RC dot dBl light intensity. That's a double again, double. And then I'm going to call the generate random function between 0 and 200,000. Yeah, that's 200,000. And then we are done. That's everything we need to write in this function. So every object or every instance of this class that gets created it's going to be initialized with this. So I need to make sure that happens. I'm still not done yet. Remember what it says. This function must be called in the constructor that does the initialization. So I'm going to call it inside the constructor that has most of the parameters. So it's this one. After I'm done setting the default values, now I need to randomize it. So set sensor data. So randomize values for each sensor. So I did that. It's going to randomize each value, each sen each sensor with random values. So these are the number of rows from the user, which is basically the height. Then there's the number of columns from the user, which is basically the width. Then the sensor says a record structure with default values, which is it's this IIoT sensor record structure to be exact. But yeah, we'll get to that. So let's okay, let's this function. Let me create a string representation, right? So let's check how we're supposed to implement it. Let's create a string representation. So the toString. So a toString function that returns a string using string stream. So I need to use a string stream. So the string stream, right? It's basically a means of me adding a stream of strings. That's basically all there is to it. So I can keep adding strings to the stream. And then once I'm done, I can format it into one big string. That's all there is to a string stream. So I'm going to create a string stream instance. So string stream, call it SS, right? And then at the end of the day, I'm going to need to represent a string representation of that string stream, of basically of that stream of strings. So return SS dot, I use the str function, which converts to the string stream to a string. Convert the stream of strings to one individual. Okay, that's a bit redundant. One string. Okay, I want it to be a bit bold. Yeah, that's fine. So let's continue. I'm gonna have, let's check these values, right? So they say that if a they say a malfunctioning or faulty sensor is defined as follows. So the temperature, if it's like this, so whatever is in the brackets, as you can see, it's a Boolean expression. So, and that means I'm working with Booleans here. So what I can do is I can say create variables to represent that. So I can say, and this is for each. This is for each. Okay, so I can create variables for that, right? Boolean values for to represent whether it's malfunctioning. Boolean variables to state whether a sensor is malfunctioning. Malfunctioning. So I'm gonna have bool, and then I'm gonna call it is temp malfunction. So is the temperature malfunctioning? So is temp by default it's false, right? We haven't seen anything. So by default it's gonna be false. Then what's the other one? The humidity is I'm just gonna abbreviate it. I don't want to have very long variable names. and then is press, yeah, pressure. Then I'm going to have is intensity. Okay, let me just write it in full. Is intensity, is pressure a function, humidity, and then temp. I'm just going to leave it as temp. That's for temperature. Right, and then now I'm going to iterate through every single sensor. So R is less than int rows R plus plus. And then for int C, and C is less than int calls C plus plus, we have those variables, right? Okay, let me see. The way I defined it is not the right way. Let me do it like this. I'm just going to initialize it to the conditions. At every single sensor that I'm currently looking at, I'm going to initialize it to those defaults. So they're saying if the value is less than or equals to 0. So let's see. I mean, how do I check? I'm using sensors. So if I don't have to make an if statement here, I can just write a Boolean condition, Boolean expression, I mean. So RC dot this is temperature, right? DBO, not DBO temperature. And then I can check if the DBO temperature is less than or equals to 0, or the DBO temperature is greater than 40.0. So I need to say 40.0, and then, yeah, because it's a double. And then the humidity, then dot int humidity, that's an integer, less than or equals to 0 and greater than 30, or greater than 30. Greater than 30. So it's gonna evaluate to a Boolean type because this is a Boolean expression. So I'm expecting a Boolean value back. So it's going to be less than or equals to 0. That's the pressure now. Dot dpl pressure less than or equals to 0, or the dbl pressure is greater than 30.2. 30.2. And then the other one is less than 0 or greater than 100,000. The light intensity. If that is dot dBO light intensity, if that is less than 0, or then dBO intensity, light intensity, that's greater than 100,000. So I have the Boolean conditions, and then now we have the toString function that's supposed to return the characters, right? So we start by checking if it starts by M. So we need to check if more than one sensor is malfunctioning. So how do we do that? That means I'm going to have a variable that counts the number of malfunctioned sensors. So int count starts at 0. And then, okay, this is an unsigned int. Yeah, because it's going to keep incrementing. It's unsigned from 0 and above. So I don't want to waste the necessary storage or things like that. So it's going to be an unsigned int. And then, yeah, I don't want to reserve memory that I'm not going to use. So unsigned int, int count is equal to 0, right? Because I'm only counting from 0 and above, only positive values. So let's count now. Let's check. So it says if, what is the question? If more than one. If more than one. So they're saying it's if more than one. So that means I need to count if, so I can say, yeah, I need to count. So I need to use variables here. So I'm gonna have a counter for each. So I'm gonna say temp. Yeah, I'm gonna call it, okay, let me say int temp, right? And then I'm gonna copy this. So basically, if I manage to find a malfunctioning sensor, I just increment its respective counter. And then I sum up all the counters and check if the sum happens to be greater than 2, greater than 1. If it is greater than 1, that means more than one sensor is malfunctioning. So I'm going to do that. So int temp and then int humidity and then int pressure and then int intensity. Intensity. So now check if any sensor malfunctioned. So let's check if any of the sensors malfunctioned. So if is temp malfunctioned, that means this is true. Remember, an if statement only executes if the Boolean expression or the condition that I'm providing within round the round brackets is true. So if it's malfunction, it means that if this variable is a truth value of true, then what? Increment the counter for temp. That means I have a thing, a temperature that's malfunctioned. And then I'm gonna check if is humidity malfunctioned. And then I increase the int humidity, increment the int humidity pointer by 1. And then I check the other ones, the rest. So if is pressure malfunctioned, then int pressure plus plus. And I'm doing separate if statements because I wanted to check for every sensor. So if is intensity or thought malfunctioned. Okay, I forgot semicolon there. And then int intensity plus plus. And then now I check, I keep forgetting the semicolon. Now I check the sum. I'm gonna have an int sum variable that sums everything. So int temp plus int humidity plus int pressure plus int intensity. I sum them up and then I'm going to check if now it's time for me to output the characters, the respective characters. So now I'm going to check if int sum happens to be greater than 1. That means there's more than one sensor malfunctioning. It means there's more than one sensor malfunctioning. So I need to add a string to the string stream because here I need to add that string, the M. So I need to add the M. How do I do that? Just use it the same way you'd use cout. So you can imagine there's like an invisible cout somewhere behind the scenes. So I'm just gonna say string stream. Remember, this string stream is the variable that I've declared at the beginning. There it is at the top. So string stream, right? And then what letter I'm going to put here, M, and then spaces in between them. Because if you check the desired output, you can see that the spaces after the character. there's a space behind the P, there's a space in front. So every single character that I'm displaying is like that. So I need to follow those requirements so that I have the exact desired output. So that's if more than one sensor is malfunctioning, right? Then do that, and then I'm gonna have an else if saying if only the temperature sensor is malfunctioning. How do I do that? Remember that I counted, right? So this either stores 1 or 0. I can either use these counter variables or the Boolean variables. It's up to me. So I'm gonna use the counter. Let me see. Yeah, I'm gonna use the counter variables. The variables are the way I've named them. It's small. It's short. But let me see. Let me see if I can make it short. So is temp mal. Let me just do it. Let me just write like that. Let me not write it in full. Yeah, let me just use mal. Then I remove. Yeah, and then I'm just gonna do a quick fix here. Select everywhere where you see. Okay, let me not do that, because now it's gonna change my comments too. So let's just leave it like that. So if only the temperature is the one that's malfunctioning. So how do I check? So I'm going to check is temp mal, right? And all the other ones are malfunctioning. The other ones are not malfunctioning, I mean. So I'm going to check, how do I do that? I use the not operator, the negation operator, basically. So I'm going to negate that truth value. So if it's not, is immediate malfunctioning, and come on, and is not, is intensity malfunctioning. What's the other one again? Pressure. And is not, is pressure malfunctioning. So only this one is malfunctioning, and the rest are what? Not malfunctioning. That means if they're not malfunctioning, that means that they're fine. So that means only temp is the one that's malfunctioning. So I'm gonna output, I think, a T. Yeah, a T. And then if only humidity. So I'm just gonna do this, copy this, and then change the values. I'm gonna put the not there. And then if only humidity is malfunctioning, so I'm gonna remove that not, and then put H there. And then if only pressure sensor is malfunctioning, that means only pressure. So I'm gonna remove the not there and put the not there. So I need to output a P. Yeah, I need to output a P. And then the last one is light intensity. Come on, not there, and then is intensity. There it is. That means I need to output an L. That's what the app requires. And then else, so if none of these conditions were satisfied, none of them are satisfied, that means I must put in a dot. And then after, if you check after this inner for loop, the for loop that goes through all the columns, once I'm done with that row, I need to output an end of line character or a new line character so that it outputs it in the grid form like this. Because as you can see, it goes through that whole row, that one row at every single column. And once I've reached the last column, and then I'm gonna output a new line character so that it starts on a new line. So I'm gonna do that. So after that inner for loop, I'm gonna say SS into the string stream, the end of line, a new line character. And then that's it. We are done with the implementation. So now we need to test it. So let's test it out. Remember, this toString function returns a string. So I need to see out the string. So see out, just like hello world, but this one returns a string. So I need to see out that string that I'm going to get back. So let's run it. There we go. There's the application. What's going on? It's not putting the right way. There's an end of line character. Let me see something here. In terms of my display, let's see. But I think my displaying, the way I was displaying is fine. And then I add a new line character. Yeah, and then it goes back to the next row. Yeah, so that's fine. Okay, I don't know why it was doing that. Yeah, so there's the output. We have the desired output. It's showing the characters, and this is randomized. So yeah, if you check this is exactly similar to what we have here. That's the output that we're expecting. Then we can even specify, use a default, the parameterized constructor. Let's say I want it to be 20 by 20. So it needs to have 20 rows and 20 columns. And then the default's just going to be 0, 0.0, and then 0 for the humidity, and then 0.0 for the pressure, and then 0.0 for the light intensity. So there it is. Let's test it out. Boom, that also works. So there's our application. It's working as intended. So let's see if there's anything that's missing. Yeah, there's nothing missing here. We have all the information, the correct output, copy constructors has been implemented, everything is there. So yeah, that's it. Let me stop recording now. Thanks for watching.